Yes, sir, start.
Yeah, you can go ahead, sir. Sharat garu.
Good evening, everybody. And today we are going to discuss a very interesting and very important concept in static electricity, where the charges never move. They are static. They are there at some surface. So today our topic is on Gauss law and its applications, how to apply this Gauss law and all. So let us, before going straight into the gas law, let us go through the fundamentals and we do some problems also today. So let us see. Yeah, I think you are looking at my notepad. Let us take, for example, we all know when a positive charge is there, yes, charge is there, the electric field lines will spread uniformly, normally in all directions like this, we know it, right? If whatever this electric field line is going, this effect we can see in this vicinity, how? See, if this electric field line is going away from the charge, here some medium will be there. So these field lines must go through this medium. So whatever the effect, this is the electric field direction. So from the positive charge, all the field lines normally spread in all 360 directions going away from the charge, positive charge. They are spreading away. So here, the effect of electric field we want to calculate, we have to know. Then before this electric field reach this place, it has to go through this medium. So if this medium allows this electric field line, then only this effect will be prominent at this place. So this medium has to allow this electric field line. This property of the medium which allows this electric field lines through it is called as permittivity. Permittivity. The symbol we use is epsilon. So if nothing is there, if air or vacuum is there, then the permittivity, we say no, we use the symbol epsilon naught. This is the permittivity. If air and medium is not there, some other medium is here, then the permittivity may be some other value. It is not epsilon naught. So symbol we use epsilon naught for the permittivity of the air and vacuum. If other medium is there other than air and vacuum, we have to use this epsilon like this. So if this electric field lines are coming out here, the more number of electric field lines comes here, we say at this area, electric flux is more. So how to calculate electric flux? Let us, for example, a positive charge is there and electric field line is there going normally in this direction straightly, and one surface is there here. This is the surface, the area small surface I have taken, so I named this surface as so S is the symbol we use for the surface, ds, surface, small surface. See, the surface is spreaded like this, so the direction of this surface is in this direction. This is the unit vector normal to this surface. So this vector, we call it as a aerial vector. This is always normal to the surface. This is the angle it makes. So if the electric flux we have to calculate in this area, so what is the formula we use for the electric flux? Electric flux is equal to the scalar sum of scalar product of the this electric field and the area normal to this area. So this is the aerial vector, we may say. So simply we write it is a small surface. So this is a small flux here at this surface, at this vicinity, at this area, at this place. So d phi is equal to, simply we may write ds bar. So the dot product we know, so ds cos theta. This is the flux at this surface. If The positive charge is here, the electric field line is here, and the surface is like this. So the surface normal, this is a small surface ds, the normal drawn to the surface is in this direction. So this is a unit vector normal to ds. So here the flux is flux at this surface at this place is equal to the dot product of E bar dot ds bar, but we know that the angle between these two, this vector and this E bar vector, we call this vector as a aerial vector. The angle between aerial vector and electric field is 0. So E ds cos theta is the formula here. You see this formula where whenever we get trigonometric functions ratios in any formula, this total value, this one, becomes maximum when this trigonometric function becomes maximum, and minimum when this trigonometric function becomes minimum. So in this discussion, the flux here is equal to the angle between ds bar and E bar is equal to 0, cos 0 is equal to 1, so EDS. So from this discussion, the conclusion is, see, if an electric field line is going through a medium, it has to allow the electric field. So this property of a medium, we call it as a permittivity. If air and vacuum is there, permittivity value is epsilon naught. If other than air and vacuum is there, it is epsilon. But how to calculate the electric flux? Electric flux is what? The number of electric field lines passing normal to the surface. So I have taken a surface. This surface is in this direction. The vector, surface vector is in this direction. The electric field direction is this one. There is an angle theta between. So here in this vicinity, the small electric flux is equal to this much value. But if it is the surface is in this direction, so the surface vector and electric vector both are in same direction. So the flux here is maximum. This is the concept of flux. But the Gauss is a mathematician. He has suggested a very shortcut method to calculate this flux. What he is telling is, if any positive charge is there, you just imagine a closed surface. You keep it charge in the center, and around the charge, you imagine a surface. Then what happens? The electric field lines are coming out normally to the surface in all directions. So what is the flux? The electric field lines coming normally from a surface is electric flux here. So how to calculate the electric flux, total electric flux around this imaginary closed surface? He says that the flux linked with the closed surface is equal to the charge inside it. And see here we have imagined this closed surface. Here there is no medium, there is no surface, there is no material, only air and vacuum is there. So this, from this vacuum only the electric lines are field lines are coming out, and from air, if air is there, it is coming through air. So the permittivity of air, here we have already discussed that electric field lines, when they are coming through, this medium has to allow it. So that property of a medium is called permittivity. So divided by the permittivity, here air and vacuum are there. So the permittivity is permittivity of free space. This is what the Gauss says. Gauss statement is the flux linked with a closed surface is equal to 1 by epsilon naught times charge enclosed in this closed surface. But before that, we got a formula here. While we are discussing about the basic concept of a flux, flux formula is actually the field, the dot product of scalar product of field and the scale this what you call surface vector. So we can have a here the flux value given by Gauss theorem. So normally its formula is electric field dot product the whatever the surface you have selected, that small surface vector, right? See, here is a how to calculate total flux is the point. If the surface is like this, open surface we call it as. Here all electric field lines are coming out, coming out, coming out. So this is the area. So number of electric field lines coming normally from a area gives flux. So this is open area. How to calculate the flux for the open area? This is nothing but integral, because so many lines are there. All this area we have to consider. So we are integrating. So integrating electric field dot product and the vector norm. This is the area. So area symbol we are normally using A or S. So yes, S bar. If the area is small, then A bar dot ds bar. Actually, this is the normal vector, normal to the surface, whatever we have selected. This is the thing. But here, see, the surface is a closed surface. Open surface, this is the formula. Here surface is closed. How to use? See, if the charge is there, if surface is closed, if electric field lines are coming out all in all directions, 360 directions, then we have to take surface integral. We have to take surface integral. Then at this particular case, we have to calculate the flux around the surface. Flux around the surface is equal to, here integration we have to take. This integration is around the whole surface we have to calculate. So surface integral E bar dot ds bar. This is the actual formula, but Gauss has given a shortcut formula. Whenever a charge is enclosed in a closed surface, the flux linked with this surface enclosed by charge Q is the charge divided by the permittivity of the medium. Here we have taken the air, so this is the permittivity of the medium. So here the Gauss law, we got surface integral E bar dot ds bar is equal to charge times charge divided by epsilon naught. So, my dear students, the Gauss law gives us the easiest way to calculate the flux linked with a closed surface. So, the surface area, the dot product of surface area and the electric field gives us the flux linked with the surface. So let us go forward. Now, see, let us go further discussion. So what we came to know is, if a charge is there, around the charge, we have, imagine a closed surface. So electric field lines are coming out normally in all directions. Electric flux is linked with the total surface, total electric flux linked with the surface is equal to surface integral of E bar dot ds bar. This is nothing but the charge enclosed in this divided by the permittivity of the free space. Suppose, for example, let us consider a square, the cube, charge plus charge is exactly at the center. So in all directions, electric field lines are coming out, right? What is the total flux linked with this surface, this cube? This is one you may be asked in the exam like this. So what is the shape of this surface in which the charge is enclosed? A cube. How many surface are there? So total charge, total flux linked with this is, according to Gauss law, phi is equal to charge inside the cube is this one. This cube we have imagined, it is not made up of any material, so air is only there here. So epsilon naught, simple. But see, here also electric field lines are coming out from this surface, also coming out from this surface. So all total, how many surfaces are there? 1, 2, 3, 4, 5, and 6 surfaces are. From all 6 surfaces, the electric field lines are coming out totally, total cube. This is the flux around the cube. But each surface, each face. So each surface. How much flux is linked with surface? So we are having 6 surfaces. We are consider one surface among 6. This is the flux linked with each surface. If 2 surfaces we have to consider, then 2 surfaces among 6 we have to consider. If 3 surfaces among this one. If 4 surfaces, this is, if 5 surfaces, this is the flux linked with 5 faces. If all 6 we have considered, then the total electric flux linked with the cube is equal to charge inside the cube by the permittivity of the free space. So like this, we have to apply the Gauss law. So Gauss law says the electric flux linked with a closed surface is 1 by epsilon naught times the charge enclosed in the surface. So if the charge is exactly at the middle of the square, this is how we have to calculate each surface, 2 surfaces, 3 surfaces, total 6 surfaces are there. So one surface among 6 we have to select. So the flux linked with each surface of a cube is equal to q by 6 epsilon naught, like this. This is the correct answer. If suppose same cube I will consider, if our charge is at one of the surfaces, center of the surface. At this surface, the charge is there, positive charge. In this, it is not at the center, it is on this surface. But according to our Gauss law, the charge must always be enclosed in a closed surface. It should not be outside. Here, if you consider, suppose I will take one. If I consider a book here, the charge is at this surface. The charge is middle of this surface. So if surface, if we, charge is here, it is exposed outside. It should not be like this. So according to Gauss law, this charge should be enclosed in a surface. So what to do? I will imagine another surface, another cube here. Then what happens? The whatever the charge we have considered at this surface goes inside this big rectangle. Then what is the flux linked with the total what you call surface? Let us calculate. See, what previously we know is, if electric field is in this direction and the surface vector is also in same direction, then flux is maximum. If electric field is in this direction and the surface vector is spreaded in this direction 90 degrees, then phi is equal to minimum, that is 0. Why? Because sin 90 is equal to 0. Sorry, cos 90 is equal to 0, right? That's why. Let us see here. See, if we consider positive charge here, the electric field line is coming out normally in this direction. And from here, the electric field line is coming normally in this direction. This is the surface. This surface is going outside like this. So for this surface, if you draw normal, the surface vector is also in this direction. Here, the surface is this one. It is also going out normally. So E bar and ds bar in same direction, right? Let us see this surface. Let us see this surface. See, electric field is this direction. See, electric field is in this direction. The surface of the surface vector direction is this direction. So electric field is in this direction, and the surface vector is in direction. So this is 90 degrees. So wherever 90 degrees is there, the electric flux is equal to 0. So this surface is equal to 0, this surface is equal to 0, this surface, all four surfaces are 0. So only these two surfaces are, but see one thing, don't confuse. See, if any charge is enclosed in a closed surface, the flux outside the surface is equal to whatever the charge inside by the permittivity of permittivity. Here we just imagining the surfaces. So air is only there. So permittivity of the free space. Okay. But how many surfaces are there here with the maximum flux? Only two surfaces. On other surfaces, the flux value is equal to 0. So from each surface, each surface, what is the flux linked? Q by epsilon naught, only two surfaces. So we are considering one surface, comma 2. So if the charge is at center of a face of a cube, then total flux is equal to Q by epsilon naught only. But each surface, the flux is equal to Q by 2 epsilon naught. Like that, many problems they will ask in the examinations. If uh, the same cube you take, if the charge is at one of the corners, see, the charge is exposed. It should not be like this. According to Gauss law, the charge should be inside. So we have to consider. So here, one cube I have to construct here, one cube, another one. So to cover this charge at a corner, I have to place here backside one cube and here one cube. Total 7 cubes I have to place. So total, how many cubes I need? Total, because one cube already there. So around this, to make this charge inside, so I have to construct 7 more uh, cubes. So total, these many cubes I have to keep, so that this charge will be inside. I think you are understanding, and it is all related to geometry. So this one, see, for example, if this is the cube, this is the book is a cube. Here charge is there. Here charge is there. So to make it inside, I have to place here another book. Here also, and upside also I have to keep. So total. Hello. Sanjay sir? Hello?
Sir, yes, sir. Yes, sir. Then
I got a
we
missed
will go
call
with
from you,
math,
sir.
sir.
Is it okay, sir?
Yes, sir. It's
Can I stop?
yeah, yes, sir. You can. Sir,
Thank you.
Sudhakar
Sir,
garu, thank you so much, Andy. Sir,
thank you, sir.
namaste, sir. Sharath garu, thank you so much.
Thank you, sir. Thank you, sir.
Sudhakar garu, please share your screen, Andy. Sorry, video on చేస్తారా మీరు? Yeah, okay, sir. You can go ahead.
Okay, sir.
Yeah, you can go ahead. Namaste.
Hello.
Yeah, we can
Hello?
hear you, sir. You can go ahead.
Yes, sir. Yes, sir. So, good evening, children. This is Sudhakar, MSc BD. Morning, already we discussed about integration. This is the most important concept in mathematics. So, already I discussed integration. It is nothing but it is the reverse process of differentiation. So, before going to give shortcuts in MCET and some logics in integration, students should perfect in formulae. So in this introduction class, first I will make you to perfect in formulae. So all of you open your books and note on this formula. This formula is very much important. Already I discussed this formula in this in the previous session. So once go through this formula are most important. All of you note on this formula first. First one, formula you have to note down. This is the formula in integration. Most important formula, all of you write once. First one is integral of x power n dx. So first, if you learn the formula, that is, then you can solve the problems. Without learning formula, if you directly solve the problems, you cannot get solutions. That is most important. So for opening a door, key is most important, isn't it? So like that, for solving a math problem, formula is most important. CDF concept. C means what? Concept. D means what? Definition. F means what? Formula. These three things are most important regarding math. So whenever you want to solve any problem, these formulas plays a vital role. So dear children, in this class, please learn formula. Next class onwards, you will get most important tips to solve integration concepts. First, I'm carefully, all of you note on this formula. First formula is integral of x power n dx is equals to x power n plus 1 by n plus 1 plus c. Remember, this is the most important formula. Already proof is there in one video. Sir will send you that formula proof. Proof is nothing but just to take differentiation for this. D by dx of x power n by n plus 1, you will get x power n. So that is most important. So that is the first formula, all of you know down. So how will you read this symbol? This is nothing but integration. So integral of x power n dx is equals to practice all these formulae. In the next session, I will interact with you by asking questions regarding formulae. Later, I will typical problems regarding this concept. Second one is most important, integral of 1 by x dx is equals to log mod x plus c. Log mod x plus c. This is most important, second formula. Integral of 1 by x dx is equals to log mod x plus c. And the third one is integral of e power x dx is equals to e power x plus c. So this is the most important formula. Note on those three formula. And the fourth formula is integral of sin x dx is equals to minus cos x plus c. Integral of sin x. This is a trigonometric formula. Integral of sin x. Integral of sin x cos. Okay. So after writing the formula, I will ask you. I will solve. I will make you to do some problems. So this formula is most important. I think Sir is asking after formula what you have to solve that thing. So already once I will read all the formula, you already know this formula. Integral of cos x dx is equal to sin x plus c, and integral of secant square x dx is equals to tan x plus c. Already you know. Integral of cosec square x dx is equals to minus cot x plus c. Integral of secant x tan x dx is equals to secant x plus c. Integral of cosecant x dx is equals to minus cosec x plus c. Integral of 1 by root of 1 minus x square is equals to tan inverse x plus c. Integral of 1 by 1 plus x square dx is equals to tan inverse x plus c. I think you are all well familiar with this formula. So let us, I will discuss some problems regarding integration. So this is the first problem. All of you look at once. Integral of 3x square dx. Once children look at this. Integral of 3x square dx. How to solve integral of 3x square dx? This is in the form of integral of k into f of x. Once you go through your textbook, you have formula there. So once read all the formula, tomorrow I will discuss this formula with you. See, this one, first one is integral of 3x square dx. What 3 is what here? Constant. So this is in the form of integral of k into f of x. That means k means what? Constant. You have to bring constant to before integration, and afterwards you have to go for integration for this one. See, bring this 3 before integral, 3 integral of x square dx. So bring this 3 before integral part. 3 into integral of the x square dx. Now it is in the form of integral of x square. What is the formula for integral of x square? Can you say? It is in the form of x power n. What is the formula for x power n? X power n plus 1 by n plus 1. That means 3 into x cube by 3 plus c. It follows by constant c. So this is the first basic problem. Integral of 3x square dx. Already you know. So bring that constant before integral part. 3 into integral of x square dx. 3 into x cube by 3 plus c. So already I think you know this problem. And next problem is, I will go for known to unknown concepts. Known to unknown concept means first I will explain all easy concepts. Next I will go for the toughest ones. See, one more problem I will explain. Integral of 5 into x power 9 plus 2 into x power minus 3 plus 1 by root x. Look at this problem once. Integral of 5 into x power 9 plus 2x power minus 3 plus 1 by root x. So what you have to do here? You have to apply this integral for all the three terms. First term, second term, and third term. That means you'll get integral of 5 into x power 9 plus integral of 2 into x power minus 3 plus integral of 1 by root x. For all the three you have to apply. So this is integration. This integral of 5x power 9 plus integral of 2 into x power minus 3 plus integral of 1 by root x. That is, bring this constant again, 5 into integral of x power 9 plus 2 into integral of x power minus 3 plus integral of 1 by root x means what? Can I write directly 1 by root x means 1 by x power half, that means x power minus half. 1 by root x means root x can be as x power half. 1 by x power half means x power minus half. Next step is, that is 5 into, this is integral of x power 9 means what? X power n plus 1 by n plus 1 means what? 9 plus 1, 10 by n plus 1 plus 2 into x power minus 3 plus 2 by minus 3 plus 2 plus x power minus half plus 1 by minus half plus 1. So like that, if you simplify, you'll get the answer. Understood? So 5 into x power 9 means x power n. This is the form of x power n. What is the formula for x power n? You know, x power n plus 1 by n plus 1. This is also x power n. What is the formula for x power n? Hello? 2 into x power minus 3 plus 2 by minus 3 plus 2 plus x power minus half plus 1 by minus half plus 1. After simplifying, you will get the final answer for this. This is all about the second example. This is compared to first one, a little bit complex, and step by step you'll go for. I will increase the complexity. Next question, see. Integral of 3 sin x minus 4 cos x plus 5 secant square x dx. So look at this problem. This is integral of 3 into sin x minus 4 into cos x plus 5 into secant square x dx. So this is also same concept. See here, integral of 3 into sin x minus integral of 4 into cos x plus integral of 5 into secant square x dx. So you have to keep dx for everyone. That is, bring this constant 3 into integral of sin x minus 4 into integral of cos x plus 5 into integral of secant square x dx. For all, you can keep dx. Don't forget to keep dx. 3 into what is integral of sin x? The formula already. That's why I asked you to revise the formula first. All of you be perfect in formula. Without perfection in formula, you can't solve the problems. So all of you be perfect in all the concepts, all the formula first. So this is 3 into sin x. What is the derivative? What is the integral of sin x? 3 into minus cos x minus 4 into. What is integral of cos x? Cos x integration what? Cos x integration is what? Sin x. So 4 into sin x plus 5 into integral of secant square x means what? Tan x. Along with next step is minus 3 cos x minus 4 sin x plus 5 tan x. Along with you will get a constant c. So this is next level integration regarding trigonometric ratios. Previous one is integration regarding algebra concept, and this is integration regarding trigonometric concept. Next one is find the integral of 3x power 5, 3x power 4 minus 5x cube plus 4x square minus x plus 2 by x cube. See this one also. Once look at this one. This problem relates to fraction concept. Okay, sir. So all of you look at this problem first. My dear children, my sincere advice for all of you is by tomorrow class, I will ask the formula first. You be perfect in formula. These formulas are most important. Without getting formula, we cannot get the problem solutions regarding integration. Now this is integral of denominator split this one. 3x power 4 by x cube minus 5x cube by x cube plus 4x square by x cube minus x by x cube plus 2 by x cube of dx. That is integral of, cancel this with this, how many times? 3x. Integral of 3x dx minus x cube cancel, minus integral of 5 dx plus cancel x square x cube, how many times? X times. Integral of 4 by x dx minus integral of x with x square cancel, 1 by x square dx plus integral of 2 by x cube dx. Understood? First, we have to split the denominator. Splitting of denominator is most important. 3x power 4 by x cube, x power 4 will cancel 3x dx, x cube is to cancel minus 5 dx, integral of 4 by x is x square, x will cancel 4 by x dx, minus x by x square cancel 1 by x square dx, plus 2 by x cube dx. Next step is bring this constant 3 into integral of x dx minus 3 into integral of x dx minus 5 into integral of 1 dx plus 4 into integral of 1 by x dx minus 1 by x square means what? You know, x power minus 2 dx plus bring constant 2 into 1 by x cube dx. That is 3 into integral of x. It is in the form of x power n. So what is the formula for x power n? N means 1. X power n plus 1 means 1 plus 1 by 1 plus 1. 2 minus 5 on to integral of 1 means we can write x plus 4 into integral of 1 by x. How can you write? X power minus 1. So how can you write? X power minus 1 plus 1 by 1 by x means what? Minus 1 plus 1. You can write like that. Minus x power minus 2 plus 1 by minus 2 plus 1 plus 2 into 1 by x cube means what? X power minus 3 plus 1 by minus 3 plus 1. So you can write like that. So here you will get 4 into 1 by x means you can directly write down here. You can apply, without using writing minus 1 plus 1, directly you can write 4 into log x. No problem. 4 into log x. Now after simplification, you will get the answer. So yeah, these are the different problems from level 1 to level 3. This is all about level 1 problems only. They are very easy problems. So in the next section, I will discuss some more complexity problems. So till then, you take some more examples of the same concept and you go for practice. But my sincere request for all of you is please learn the formula. Without getting formula, you cannot solve it. Thank you, children.
Thank you so much, sir.
Thank you.
Sudhakar garu, namaste andi. Yeah, Gupta garu.
Sir.
You have last 12 minutes left.
That's what, sir. I'm waiting, sir. Again, I have 5 o'clock here. Shall I start, sir?
Go ahead, sir. Go ahead.
Okay. So good evening, students. Yesterday, regarding solutions topic, we already discussed about molarity. On topic already we discussed. I gave an explanation, the definition of the molarity, and 2 more problems we completed yesterday. And now, in that normality of a solute, now we are going to discuss about the normality of a solute. It is defined as the number of gram equivalent weight of the solute present in 1 liter of solution. Again, I'm telling it is defined as number of gram equivalent weight of solute present in 1 liter of solution. So here always the normality is indicated capital N. Normality is indicated as capital N, and units of normality is liter inverse. The unit of normality is liter inverse or 1 by L or 1 by L. So again, I'm repeating before entering into the formula. It is defined as number of gram equivalent weight of a solute present in 1 liter of solution. So already the formula I have written on the board. So normality is equal to weight of the solute by gram equivalent weight into 1000 by volume of solution in ml. Volume of solution in ml. Yesterday also, if he has given the problem in liters, it is our duty to convert the volume from liters to ml. So now in this case, see here a small calculation. calculate the weight of NaOH present in 500 ml of 0.5 normality solution. Again, I'm repeating the question. Calculate the weight of NaOH present in 500 ml of 0.5 normality of solution. So here, what are the things? He is asking small w, weight of the solute. He is asking small w by gram weight of NaOH. What is NaOH? NaOH is nothing but sodium hydroxide. Sodium hydroxide. So what is the gram equivalent weight of sodium hydroxide? 40. Yesterday I already told that sodium hydroxide, we can divide sodium plus oxygen plus hydrogen. 23 plus 16 plus 1, that is equal to 40. So 40 into 1000 by volume. What is the volume? Calculate the weight of the NaOH. 500 ml. Already here normality given. N is equal to how much? Normality given 0.5. So normality is 0.5. So now see here, 500 ones are 500 twos are. So 0.5 into 40 is equal to 2 into W. W is nothing but weight. W is nothing but weight. So 0.5 also can be written as 5 by 10 into 40 is equal to 2 into W. So 2W is equal to 20. W is equal to, so what is the weight here? The weight is 10 grams. But actually, in EAMCET question point of view, this much of not, there will be no this much of time for calculation. Simply the formula. So that's why please remember the formula. Only the already normality has given. He is asking weight. Now, if he will ask in another way, if he will give in another way, like percentages, then what we have to do? One more question simply, I will conclude. Calculate the normality in another way. See, calculate the normality of 4% weight by volume. See here, this is important. Weight by volume of solution of same NaOH. Of same NaOH. So again, the same formula, weight by gram equivalent weight into 1000 by V in ml. 1000 by V in ml. Now here, what is weight? Calculate the normal 4%. He has given 4% of W by V. Means totally of weight by volume. In totally, he has given 4. So 4 by already gram molecular weight already given, gram equivalent weight already given, already we know, already we calculated here NaOH 40 into 1000 by volume how much? By volume. Calculate the normality by volume 100. By volume 100. So then 4 ones are, 4 tens are. So that is equal to 10 by 10 is equal to 1. So the total normality is 1.
Sir, excuse me, sir.
Sir.
Can you repeat it, the second one again? The net was gone and reconnected again. Please go.
Okay. Calculate the normality. Here 4% of weight by volume he has given. Volume, weight by volume 4% he has given. So 4 by, already we discussed the gram equivalent weight 40 in the previous problem, how we got the 40. So 4 by 40 into 1000 by, for 100 ml, per 100 ml 4%. That's why in volume I have written 100. So 4 ones are, 4 tens are, and here 100 in 1010, 10 gets cancelled. Now the final answer is 1 normality. So what are the differences between these two? The previous question, he only given the normality and is asking to find out the weight. But in this question, 4% of weight by volume he has given and he is asking to calculate the normality. So these are the 2 to 3 different types of calculations in the normality. Now coming to the molality, today I will explain the molality, and tomorrow let us consider the examples and the problems in molality also. Molality means it is defined as number of gram moles of the solute present in kilogram of solvent. Yesterday I already told, maximum solution is depend upon two things. It means entire the solution to a lesson or topic plays a vital role in between the two things, solute and solvent. Maximum solutes are nothing but the solid particle or solid material which is present in the solution. For example, yesterday I told sugar solution means sugar solution mananta panchadara needlu. So that entire it is a solution. What are the components in that? Sugar and water. Here sugar is known as a solute and water is known as a solvent and totally solution. So, but you may ask one more question. Sir, liquid plus liquid is also solution, is there? No. Milk and water. Yes, it is also a solution. It is also a solution. But maximum solutions are made up of or combined of solute and solvent, solid and liquid. And milk and water is also a solution. And naphthalene and petrol. Being naphthalene is a polar solvent, non-polar solvent, and petrol is also a non-polar solvent. So both can mix. But naphthalene will not mix in water. And in the same way, camphor will not mix in water because water is a polar solvent and the naphthalene ball, naphthalene ball is a non-polar solute. That's why they can mix it. So in the same way, again, I'm repeating the molality. It is defined as the number of grams of moles of solute present in kilogram of solvent. Present in kilogram of solvent. So already it is indicated as small m. And the units are kg inverse. Here for normality the units are liter inverse and molality the units are kg inverse. So these are the differences between molarity yesterday we completed and normality and molality. On these nearly 2 to 3 problems will come. You can face across the EAMCET examination. Thank you. Have a nice time. Sir. Moles of solute present in kilogram of solvent. So solvent is indicated as water and the units are
okay.
Hello.
Yeah, okay, sir. Thank you so much, sir, for your valuable time, all of you. Shrath garu, Mariu Sudhakar garu, and Gupta garu. Thank you so much, Andy.
Thank you, sir. Thank you, sir. Thank you.
Yeah, stop recording.